thanks everyone for coming. This is our December meetup. I see quite a few familiar faces, but also a bunch of new ones. So I want to thank you all for coming on this pretty cold winter day. So I'm glad that you made your way through the cold Estonian winter and managed to come here. So I'm pretty happy to see that this is basically a full house. We got a ton of people. And today's event is definitely going to be worth it because we're joined by Heikki Kolk, and he's going to talk about e-power and the decentralization of electricity. If you're new to the meetups, then we do these kind of meetups every month. We have different speakers, and it's a great opportunity to network with like-minded people and to discuss on crypto-related topics. So we've been doing this for since the middle of last year, and the events seem to be pretty popular. So I'm glad to see that people are still excited about crypto, even when the market has, kind of gone down. And yeah, if you'd like to follow more about our events, then you can either follow us on Facebook or Meetup, or we also post the event tickets on Eventbrite. And today's event is also going to be live streamed for the first time on Facebook. So this is kind of a thing that we're testing, and hopefully it goes pretty smoothly. So in the end, we can even possibly include some questions from the online audience. And there's one more thing that I can. Oh, and another thing I'd like to briefly mention that we have also two new co-organizers. So we have Tatiana and Kilin. So they're in the back. Great time. So they've done a bunch of really great work in order to help today's event become fruitful. But yeah, without further ado, I'm gonna hand the reins to Heikki Kolk.
Thank you. Good evening and welcome from my side as well. Yes. My name is Heikki Kolk, and I am telling you about a case study on Ethereum based on e-power's use case. But first about my background. So my main background is actually energy. So mostly I work for biggest Estonian distribution network operator, Electric, and during the 10 years I was there, I was practically connected with all the big IT developments that took place there. So different roles there. But at one point I thought that this is not big enough, so I decided to join the Catapult team, and today I'm the managing director of Catapult Lab. So what we do in Catapult is we provide consulting and IT development services for critical service providers and utilities, and also consulting services, integration, security risk assessment support, business analysis, blockchain, GDPR, so all the main things. And based on that, about a year ago, I was approached by e-power, who was they were planning this ICO to take place in February, and I joined their team as a solution architect. So today is Catapult Labs, one of the biggest strategic partners of e-power. We do development, both the regular IT platform side and the blockchain side. But they are building a bigger team already in Estonia as well, on their own premises. So actually most of the e-power zone engineering team is also in Tallinn. So latest thing is that I'm also of counsel in a law firm called Legal. The reason for that is that, for example, all these blockchain and smart contract use cases, there are a good example that this technology and law must go hand by hand, because you cannot say where is the difference, because the contract is in the code. So it should be treated as the same. But before I go on, I would like to ask, what is your interest today here? What you would like to hear the most? To talk more about the things that are of interest to you, and less the things that you already know. So, what are the expectations? Please share. Share? Nobody else? Okay, so in that case, I assume that I basically cover everything that I was planning. One more thing is that although if you have any questions, please ask them directly, because again, I believe that this is more use for you as well. So don't hesitate to ask whenever you have the question. Okay, now about willpower. Willpower as a company and their vision. So the main goal for willpower is not to do great stuff with blockchain. The main goal for willpower is to help build a sustainable future by helping to raise funds for the green energy projects around the world. So currently the most active market for willpower is Australia, and that's mainly because this for Europeans, this Australian market is kind of interesting from energy side, because I would say that in Europe there are no
big energy supply problems, but in Australia there is. So this times when the electricity is just cut off because there are not enough generation, it's not so uncommon there. So Australia clearly needs more electricity generators, and preferably, of course, green ones. So it is a perfect fit for V-Power to work in Australia to help solve the actual problem there, to use more green energy. So how it's set up there is that although there are well, basically the power plants that are being built there are quite huge, and there's a lot of them. But the problem what exists there is that to be able to finance the projects, the power plant builder must sign contracts with the customer to make sure for both sides that the customer is buying the energy from that exact power plant, and the power plant owner must have this kind of contracts to show for the bank that I have enough customers and you do not have to worry, I can pay my my loan back. But what's the problem there is that as the power plants are quite big, in average they are 1,000 megawatts actually. It is quite hard for the generator as well get this kind of big customers to buy electricity from them, because 1,000 megawatts is a lot of energy, and there are less than 10 companies in Australia that actually could use all those electricity. So what they're looking for is to find a way to sell energy also to smaller companies, so that they could team together and buy the electricity collectively from one generator. What's one of the obstacles for that today is the fact that for average corporation, this contract discussions and the signing period is 6 to 24 months. Because all the negotiations are quite hard there. One of the reasons is that there are so few actual buyers that the buyer tries to get a good price, which the generator cannot afford, and so on. Actually, there is a situation when there is not enough energy in the market. There are blackouts. There are customers who would like to buy electricity straight from the generator, but they can't. So what V-Power is planning to do there is to standardize this kind of contracts, so that it is very easy for the buyer to agree between the buyer and the generator to cut down the negotiation period. So one of the enabling technologies to do that is smart contracts on blockchain. So for V-Power, it's not about the blockchain technology, that blockchain technology is cool and we would like to use that. That's also true, but for V-Power, it's mainly the mindset behind the blockchain. This transparent and kind of trustless logic and decentralization. So again, one obstacle in Australia is that nobody likes the retailers, because their profit margins are pretty huge. So V-Power is not trying to become just the next retailer. The idea is to give companies the tools to buy directly from the producer. So this peer-to-peer and decentralization logic is what what we like about blockchain, well, blockchain, this mindset behind that. So as I said, although we like the technology, but there are actually several challenges to be solved on Ethereum, for example. So that our current approach is a hybrid solution. The vPower platform is not built 100% on Ethereum. It's because several reasons. The actual transaction speed is not enough to be able to store all the needed information on chain. It is very costly. And also this Australian regulation is that not everybody can buy electricity. Obviously, it's not only Australian regulation, it's also coming from the pure physics. To buy electricity, you need to have a place where to consume it. So in any case, we need some central body who checks do you have the connection point in Australia or not. So for the first part, the blockchain is used to create trust, provide transparency, and to enable this trading of this kind of contracts. Because also what I didn't mention before is that one obstacle for these regular contracts between the generator and buyer is that those contracts are agreed upon for 6 to 10 years. So a lot of things can happen in a 10-year. So companies do not want to tie themselves to the one contract. So they would like to get liquidity also out of it. So tokenizing the contracts is vPower's solution to provide this kind of liquidity. And the bigger goal for that is that when this is done, it also creates a possibility for this asset-backed tokens or this to give something tangible on chain to trade with. So one of the questions that I have received quite often is why Ethereum? The short answer is why not? Because as I said, the vPower's platform is not built on chain. It uses blockchain to fulfill some needs, and it is built up so that it is kind of technology agnostic. So we are able to switch the blockchain that we are using, and for that reason we initially chose Ethereum, mostly because it is proven that it is viable, at least for some time, this Ethereum Casper network hopefully lives longer, so that we are reasonably sure that Ethereum network exists also after 5-6 years to be able to serve those contracts. But of course, we are looking around to find a better technology to bring even more functions on chain. And that's okay. This why Ethereum was one question. The other question I've got a lot is that why you are not using some private chain. The reason for that is what I said before, this mindset. Having a private blockchain kind of centralizes things again, because you have some quite small round of entities who control the network. So it is not it is decentralized in a way that there are several nodes, but to actually provide centralized not only this technically and computationally, but also control-wise, so that the control of the network is not in one place. So that is the reason why we discarded private chains right now. Okay. Before I'm going to the tokenization pilot that we did in Estonia, do you have some questions about rationale on Ethereum and so on? Financial model of V-Power. V-Power's financial model is that V-Power is charging the generators to participate in the auction. There's an auction model that the generator kind of sells the capacity, and based on the capacity there are service fees. Plus this secondary trading, that if some company has bought, for example, 10% of the total output and tries to sell 5% after 2 years, then also based on those trades, there's a service fee. Well, I wouldn't say that the Power Ledger is our direct competitor. Sorry. And also, I wouldn't say that it needs to have a big user base. I would say that there needs to be a reasonable amount of finances flowing through the platform, and that's the reason why V-Power is focusing on B2B market. So we are dealing with initially with big customers, so that the expected trades that we are bringing to the platform, they are 6 figures, 7 figures, so millions. So it's the amount of energy flowing through the platform, not the user base. And that's also one of the distinction between vPower and Power Ledger. Yes, there are. The negotiations have gone basically since the beginning of this year. So yes, for the big corporations, this sales cycle is again 6, 12, and even more months. But we are still quite optimistic that the first successful auction will be held somewhere around February. So current model, I would say, is not 100% fit for this asset-based currency yet. But answer to the second part is that the token right now is not related to the amount of energy, but the amount of capacity. Because one of the challenges that we are facing is for renewable energy, it is pretty hard to guess and forecast how much energy will be produced today after 10 years. And to record the production after the fact. It's also not so useful because you cannot trade it in front. So that's why we have decided to go with the this capacity partial ownership of production capacity. So that, for example, if there is a 1,000 megawatt power plant put on the auction, and you purchase 1% of it, then you will get the energy that, well, 1% of the energy that the power plant is able to produce. So it will not be bigger than 10 megawatt hours per hour, and it's probably a lot less. So it's not so easy to understand outside the energy people, but we're working on it to make it more tangible. So this platform, it is we are dealing with forecast values. For example, if you purchase from the auction, it shows you kilowatt hours still, but it is estimated numbers, so it's not a guarantee. And to build something on estimation, some currencies, it's not a good thing. Not right now, but after we have proven the business case in Australia, there's plans to expand to other countries as well, and well, there are different regulations over the world, so hopefully at some place, at some time, it will be possible. So first question was about asset-based The honest answer is that, as I said, this building stuff on blockchain is not the primary goal of vPower. So mm-hmm. This is not the goal for vPower right now. So I said that it will create possibility to do that, but this is not fixed on the timeline right now. So it is it's based a lot on the ways that we can fit it into the different regulations. So if we can do that, we will do that. But this is something that it's just somewhere there. But we are focusing on right now to solve this electricity distribution and this energy purchasing contracts. So this is the main goal right now. The second question about power ledger leaders having political offices. Well, we believe that that the market and user base also have some power to give us leverage. So let's wait and see. Nord Pool. So I would say that in a way they are similar, but I used to in the beginning of the year, when I was talking about explaining what is the vPower's goal, then I used to say that one of the goals are, for example, in the Nord Pool example, right now, if you want to participate in Nord Pool, the this yearly fees and all this what's the term? Well, anyway, this costs to participate in Nord Pool, they are very high. So our goal is to lower the margin to be able to participate on this energy market. So basically, what I used to say is that we would like to open the Nord Pool-like services for regular people as well. So pretty similar in a way, and totally different in another way, because this auction logic is a lot different. This how this market price is reached. So in that way, it is different. But unfortunately, I'm not so familiar with the Nord Pool price settlement logic. So overall, pretty same. So looks like no more questions right now. So closer to Estonia. So first, the tokenization pilot. A few months ago, we tokenized the whole Estonian electricity consumption and production for a year. So we created, it was 39 billion tokens, if I remember correctly. By that, at that time, we used this ERC20 standard like tokens, highly modified, but ERC20 like. In Estonia, there are roughly 700,000 customers consuming electricity in Estonia. The total energy that we were tokenizing was 24 terawatt hours. Yeah, that's the energy numbers. So they are just numbers. So first, I would like to speak a bit why we did it in Estonia. We were partnering with Estonian transmission network operator Elering to do that pilot. Because they are one of the few data hubs in Estonia, in Europe, that can provide easy access to meter data. Plus, they have worked out a way to share that information anonymously. So we could, well, the data in Estonia was accessible. The data in Estonia was complete because in Estonia we have 100% smart meter coverage. So all well, due to technical reasons, actually not all, but most of the energy was taken into account. But still close to 100. And well, I would say that one of the reasons are also that people in Estonia are quite tech savvy, so we like cool stuff. So, and it's nice to say that, well, we tokenize the whole country's electricity. Why? Why not? So that's why Estonia was a good country for the pilot, and the data size was also reasonable. So why we did it, besides it was cool, was that we wanted to test the token logic, this partial ownership of the production. So we tested that. We wanted to know what actually means storing a lot of data on blockchain. So these what were the this 6 billion data points. It was this initial amount of data. So we calculated. Fortunately, we did the calculation first, not just start writing the data and afterwards find out that we couldn't write the whole data because to write all the hourly measurements for all the 700,000 customers in Estonia for a year, it would have cost us, based on the prices at that time, it would have cost us approximately 200 million euros. So we didn't do that. What we did was played with different compression logics to be able to reduce that data. We tried both trying to fit multiple values into one this uint 256 variable, but well, it didn't give us so good ratio, and the data retrieval was also even worse than it is usually for the blockchain variables. So we didn't use that. What we came up with was that we just ditched the idea to store all the hourly measurements on chain, because for our use case, actually this monthly period is good enough. Because the logic right now is that the prices will be calculated once per month. Not the prices, but this settlement that to calculate the bill. It is done once per month, and as it's currently more of a financial platform, not energy related platform, it is good enough. So again, this Ellering's Data Hub integration. In Australia, there's fortunately also this AEMO, who deals with most of the smart meter data. And actually, not easy task was to map the production and consumption values, because if you have one big, well, a few big generators and a lot of small consumers, then to actually map together who bought energy from what power station, it's quite difficult, because you cannot track the electrons directly that from what plant it came from. So it proved also quite interesting task to figure out how this how those numbers come together. Fortunately, again, for when we are looking only the finances, then it was a lot easier. And this gas cost optimization was also an issue. For example, one hypothesis that we tested was that if we have if we need to store a lot of data fast on the blockchain, then if we throw enough money towards the miners, can we just get the whole bandwidth of the Ethereum? Well, it was a quite costly test, but the answer was no. So our tests said that technologically there is a limit of how much data you are able to push through. So it's not reasonable to throw too much money into it. Well, basically, where we got to was that these well, better graphics are on this. We have this GitHub white paper, or not white paper, but this technical report in GitHub. You can find the link from vpower.network/tech. There's the overview and the link to GitHub as well. But basically, our results were that just place a bit more than average. No need to go for the this what's the term was there, this this well, in this this fast the gas price to get this fast result. It's more reasonable to use just a bit above average. And you can see that actually the results were all over the place, and no direct correlation between price and the waiting time. So there are well, the time of the day was some correlation between there, but actually so far we do not have a clear model to say that what caused the longer or shorter waiting times. Yeah, here's this basically this is a small graph about saying that we have this integration layer in between where we can basically isolate the blockchain from the vPower's platform, so that whatever chain is here, we do not need to change anything here, and everything works. And this part is the thing that we tested, how to write efficiently data to the chain. As I said, the results are all over the place. So actually, nothing more to say there. Say here that well, these were the results. Why they are like that? Too soon to tell. Some more analytics needed. Yes. So, from our point of view, random events that you cannot predict, basically. So.
The network is still being developed. It's not a perfect, complete network. And you talked about direct ACT graph.
Sorry?
Direct ACT graph.
Okay. As I said, we took Ethereum as a baseline, and the next steps are this comparison with the Ethereum baseline to other technologies. So, answer is not yet. Right now, what we do basically is that based on the auction results on the vPower platform, we just create the smart energy tokens based on those results. So there will be one token per 1 month of the contract. So if it's a 10-year contract, there will be 120 tokens, and the ownership of those tokens will be divided or this kind of shared. So it's this one of the testing that has been going on is to find a good standard for that, because to be able to use that logic, the ERC20 is not enough. The ERC721 is too it needs too much resources for it to be feasible. There have been one promising standard was 831, if I remember correctly, this divided ownership, but also it doesn't fit good with this electricity market logic, where you have to so this 831 standard is basically dividing only one token, so they cannot handle 120 tokens. So our approach is that we are using our own standard, but still we are creating tokens that can be interacted with our defined standard, and most probably we will modify also some hardware wallets to be able to handle those standards. So a lot of customization. Asset ownership part, yes. So what we store there is that we store the information who owns what, and based on that we are also planning to give out this kind of proof of origin, so that based on those tokens, you can say that, okay, I owned X amount of capacity from that power plant. It produced Y amount of electricity. Hence, I have used Z amount of green energy. And we are planning to give kind of certificate to prove that you have been so green. So just tracking the ownership, basically. So short about the next steps. So one of the biggest tests are going on right now. How to change the code that shouldn't be changed. It's very interesting topic and can talk another hour based on that. But in short, our solution right now is not to use the proxy contracts and this nice delegate call function that can create a lot of nice problems. But we are just mainly we are separating the logic and the data into different contracts, and then build up a logic so that we can swap this this part of the contract that handles the logic, how, well, for example, if you want to introduce a new trading feature, then the information who owns what tokens, that must remain the same. But we need to introduce a new function how the ownership can be changed. So we are doing it via multiple contracts, and one contract calls the other. without this delegate call. Then after that, we play with these hardware wallet ideas to make it even more secure. As I said, those customizable hardware wallets are great interest of us. Yeah, then this log chaining for basically audit log, trying to well, this how this trading part will take place. That's there are some open issues there. Different technologies, and one of the goals are to do also the settlement part on chain. It's the part what I said, how to be able to give up the proof of origin certificates. You need to write down also who produced how much and who consumed it. So for that we need to do the settlement part as well. Okay, but as I understand, my time is up now. If you have some time for the questions.
That's the reason why we are building it up so that it's technology agnostic, so that when needed we can swap the technology out.
So basically, blockchain is kind of outsourced outside your network. So you send some data that need to be put on the blockchain.
Sorry? Yes. And that will be put on blockchain.
Immutability, if you're supposed to spend the whole IFC that's emitted on us, again makes no sense. If Bitcoin has to sustain at its levels when it reaches $29 million, sorry, 21 million BTCs, and you want to actually power the whole node worldwide, keep it running, and support the entire ecosystem, it will consume more electricity than what is being produced right now on the whole planet Earth. So it's not sustainable. Depends on the data that comes. As I said, this debate can go for days and it never stops.
Any more questions?
Thank you.
Thank you, Heikki, for this awesome presentation. It gave us pretty good insight into the decentralization and tokenization of electricity. And I think it's a really important project because allowing tokenizing electricity in future, it can really help provide electricity access and allow to create infrastructure even in the more remote areas of the world. So areas where currently there may be limited coverage. In future, if you have like a tokenized and decentralized solution, then people can build their own infrastructure and use tools like WePower to basically help solve the infrastructure problems in certain key areas. So I think it's really cool, and the decentralization part helps make sure that there isn't any unneeded or unwanted middleman along the way. So again, thank you, Heikki, for the presentation. And we'll be having sort of like a networking time for now. We have some time remaining, so you can just like, if you have any more questions, then you can ask Heikki, or you can get to know each other. And once it's 9 p.m., then those who want to come will be going to a bar in the old town. So if it's like kind of cold outside right now, you can get a warm, hot glöggi or any other drink. So it'll be just, you know, continue the conversation there. So thank you all for coming, and hopefully you can all meet each other now and get to know each other. Thank you. Oh yeah, and one last thing. If you want to check the video of today's presentation, then we'll be uploading it on YouTube probably. So just keep in mind. And again, thank you.